All right, so again, all we want to do is find the derivatives. So again, these are quotients, so we're going to use the quotient rule. So if we've forgotten since the last time we did some, it's bt prime minus tb prime all over b squared. All right, so first one, f prime of x is equal to what? All right, the base or the bottom is going to be e to the x plus 2 times the derivative of this, so that's going to be a 3x squared. And then we're going to subtract off the numerator, so that's x cubed times the derivative of this. Well, when you take the derivative of this, what happens is our 2 just disappears, and e to the x, the derivative is just e to the x. And then that's all over e to the x plus 2, the quantity squared. Now, because I can see this, this would be one way to write it. Now, could we simplify it to something else? Yeah, we could go ahead and multiply it all out, but I don't think it's going to help us any. If we did multiply it out, it's going to be what? It's going to be 3x squared e to the x, and then it's going to be a plus 6x squared, and then it's going to be a minus, and then it's going to be e to the x, x cubed, or x cubed e to the x. It doesn't really matter. All over e to the x plus 2 the quantity squared. So either one of these work. This one just you had to do a little more work to get to it, and you got, a little bit simpler, but it's not too much. So I think on this case, either one of these would be appropriate as far as your final answer. All right, what about the next one? All right, so f of x is equal to, or f prime of x rather. Well, it's going to be the bottom, so it's going to be a 1 plus ln of x times the derivative of that. That's just going to be a 4 minus, and now we have 4x times the derivative of that. Well, the derivative of 1 is 0. Derivative of that's going to be 1 over x. And then all over 1 plus ln of x. Okay, and that's squared. Now, can we simplify this? Well, yeah, it looks like we can because it looks like that x cancels that x. And then what we could do, it looks like we could factor maybe. And so if we did that, we have, well, maybe we should distribute, maybe. Let's distribute first. So we have 4 plus 4 ln of x minus 4 all over 1 plus ln of x squared. Now we can see that those cancel easily, that and that. And so we get 4. Okay, there, ln of x all over 1 plus ln of x squared. All right, so that would be then our final result. And so that one, I would say, yeah, we have to take it down because so much stuff does cancel here. It didn't look like anything was cancel, and it didn't when we get down to this point, but this one did because those cancel, and then we have that 4 there. So that one we had to do a little bit more work. All right, so let's go ahead and do the next one. I had space there in case we needed time or extra room, but we didn't. So we're going to refer to example 6, and we're going to basically, we want to find, for example 6 said, find s prime of t, s of 12, s prime of 12, for interpretation, and then in C, use the results from B to estimate the sales after 13 months. So the key difference is we have a new function. All right, so s prime of x, or s prime of t rather. S prime of t is equal to what? Well, it's going to be the bottom, t plus 3, times the derivative of the top, which is 150, minus the top, which is 150t, times the derivative of the bottom, which is 1, all over t plus 3 squared. All right, now can we simplify? Well, yeah, we could take that and multiply it. So this can be 150t plus 450 minus 150t all over t plus 3 squared. Well, if we change color so when we see it cancels, that cancels that. And so we just get the simple 450 all over t plus 3, the quantity squared. All right, so that's going to be kind of our rate of change. So it's going to be thousands of games per month. So that's how much we're changing. Now, B says, okay, well, let's plug in and find out what S of 12 is. And then we're also going to find out what S prime of 12 is. Okay, well, S of 12, we're going to take 150 times 12 divided by 12 plus 3. So if we multiply that on the calculator, we get, let me get my calculator out here. So we get 12 times 150 divided by 15. So it looks like it's 120. And this one is going to be 450 divided by 15 squared. So that looks like 2. All right, so now is when we're actually going to put our units on, because at this point, what we have to do is interpret it. So it says then 12 is what T is. So after 12 months, what's going to happen? Well, the total sales S, and S and 5s look horrible, was what? Well, it was 120. Well, this is thousands of games. Remember that. So I guess we could put it on there so we remember thousands of games was 120,000 games. And it was increasing by this much because it's a positive, increasing by 2,000 rather. Maybe we should write that in there. So this is 1,000 games per month. So 2,000 games per month. Okay, so that's what it's saying. So this one says after 12 months, it's has a sales of 120,000 games, and it's increasing because it's positive by 2,000 games per month. Okay, and so C then says, okay, well, with that said, what is it going to be in 13 months? Well, at this point in time, it's going up by 2,000. So if we have 120,000 here, we've gone up 2,000. That means it's going to be 122,000 games and at t equals 13 months. Okay, now can we do it past that? Not exactly, because that's where the tangent line is at that point in time. So we know the exact next one, but we don't know what 5 from there are. So that's kind of the key here. We can use it for the next month, but not the months after that. Okay, so that's all I have for this chapter or section. So hopefully that helps.